All right, good. Hi, I'm Brad Green. I manage the Angular projects, AngularJS and Angular Dart. And thank you all for coming. It's full house. I know some of you got on the wait list, and we're happy all of you could come who came. Tonight, we've got a couple announcements like we always do. Ben from Dream Factory is going to talk about building apps on RESTful UIs and making it easy, RESTful APIs. Mishka will come up. Mishka is the creator of Angular. He's going to come up and talk about how the change detection, or the thing that we experience as data binding, how this is implemented, and a few of our thoughts as we move towards Angular 2.0. And James from the team is also going to talk about how we're doing benchmarking. We're very focused on performance in the Angular team, and we've got some new tools that will make it easier for us and even for you folks to do your own benchmarking. So some announcements. It's been a while. We didn't do a lot of announcements last time. So we've had a lot of versions since the last time we talked to you guys. So AngularJS 2.9 through this 1.3 beta 1 release. If you're on production, you should stay on the 1.2. The 1.3 release, we are stopping testing on IE8. And so this is really a forward-thinking release. We'll go through a couple revs before we decide that it's ready for use. So 1.2 is the branch for you until we get that right. We've done a lot of things here. We fixed like 162 pull requests and issues. There's been a number of features. We're supporting a bunch of the new HTML input types now, like date, time, month, week, all these cool things. We added a bunch of animation support, and there's actually a whole bunch of different animation things in there. But one of the things we added was form validation states and be able to trigger animations based on if something is pristine or valid or invalid. We added a hook for DOM callbacks from the animation. We're using request animation frame for some better performance rather than timeout. And there's other performance enhancements in there as well. So a lot of cool stuff. On Angular Dart, we only had 5 releases, but you can, if you've been tracking us for a while, our release speed is picking up. We actually beat the AngularJS side on the number of PRs closed by a lot. So Mishko and a bunch of the other folks have been super busy on this. We added a bunch of the things we've been familiar with in AngularJS, like animation and forms. And there's a new change detection algorithm that's super fast, and Mishka will talk about that tonight. Other things we added, this thing called ng-repeat. It also has another super cool feature that we'll be bringing on the JS side, but it's actually only available in Dart right now, which is, we'll call it automatic digest, where if you're working with something that's on a timeout or in a third-party library, you no longer have to call apply yourself. Happens automatically. Couple cool things, not a lot of big announcements. We got some nice kudos. One thing, the Stack Overflow folks, actually this is you guys, told us that Angular was one of the top 3 exciting new technologies of 2013. So thank you guys, that was awesome. So another cool thing on GitHub, we appeared in the top repositories with most contributors and repositories with most stars. So thank you guys for that too, that's wonderful. Woo, yeah. Okay, I'm almost at the end. Last thing, we are out of presentation ideas. We could come up here and talk to you guys, but we'd actually rather hear from you folks what's going on. If you're interested, here's a link to go fill out a form. I will tweet this out later, so you don't have to remember it or write it down. But we'd love to have some of you guys come up and talk about your experiences. So come chat with me afterwards. If you don't remember it, I will tweet and Google Plus this link later, and we can chat about what you guys might do. So thanks very much, and we'll welcome Ben up to talk about RESTful APIs.
Great, thanks, Brad. Welcome, everyone. Thanks for coming tonight. Let's turn this off real quick. So my name's Ben. I'm with Dream Factory, and tonight we're going to be covering, I think, what's hopefully a pretty interesting topic for folks. We're going to be talking about Angular and how to make it easy to use Angular with REST APIs. So kind of jump into it. We're on a live stream, so if folks want to go to Crowd Sound, and there's an Angular room there, just click on it and you can enter questions in, and we'll try to get to as many of those as we can at the end of the talk tonight. So kind of, I'm going to talk about three kind of key areas. I'm going to talk about, in the first place, provide a little bit of context, like why REST services, like why are they good, and what's happening broadly speaking in the world of applications, particularly, as it relates to mobile. And then I'm going to give a little bit of quick storyline about what we've done at Dreamfactory with our open source product and kind of the challenges that we faced and kind of the reasoning behind it and why we built this open source platform that we're working on. I'm going to talk a little bit about Angular and REST generally as well, just the kind of built-in capabilities of Angular, and try to point people to some resources there, because I think there's probably a diverse group of folks here with different experiences and experience levels with Angular. And then we're going to go through the second half, about 20 minutes, walk through a demo. A simple application, but it's going to showcase a new open source library that we just released to make it really easy to consume and use REST services with AngularJS. So a little bit about me. I'm a technology evangelist at Dreamfactory, which just means basically I do a lot of developer outreach and work closely with our engineering team. We use Angular a lot at our company, and we'll be showing you that tonight. And then I have experience as an engineering manager in the mobile space on the consumer side. And I've done a lot of product management in the enterprise software as a service realm. And I've been working with REST services for a long time, especially with the Salesforce.com platform, which, when they started building that, and I've kind of learned a lot along the way. So a little bit about just kind of like evolution of applications. So I won't spend too much time in there, but we're in this interesting time with apps, right? Like web applications with HTML, generally, you click, you get a page back. You're doing a lot of this business logic on the server side. And the application itself is coming through a web browser. And you've typically got traditionally like a relational database on the back end. So in that kind of world, HTML kind of contains everything. You've got your graphics and your layout and scripting and everything in that and in HTML, and that's coming over the wire, which works really, really well for the web and with web browsers. But things have changed. So in 2007, the iPhone shipped, and I would call it this mobile era that we're in now sort of really began to take off. So this idea of kind of thick client applications or single page applications is really starting to really emerge. And here what we've got on the front end is all these devices, not just a web browser, phones, tablets, and you can actually think about things that it's actually probably going to happen real quickly with sensors and wearables and things like this, where you're really just using, instead of this big monolithic application server in the middle, you're really using REST services, or that's a really good way to architect applications, especially data-driven applications. And then on the back end, you've got this diversity of sources, like it could be SQL or NoSQL, or cloud deployments, platform as a service, broadly speaking. So we're kind of going in this world of HTML to JSON, and this is particularly relevant, if you're just building a really simple kind of static mobile application. Sure, like you don't need a back end, and you don't need to transmit anything. But if you're doing something that's data-driven, it's like you still need to use all of those data resources that are out there, particularly if you're working, say, with a big company and you're trying to deploy these mobile applications. You're not going to just start a new database in the back end, so you need to access that. And JSON's a really good mechanism with REST to get at that data and to return it to the client. So what's really cool now is there's like all this rapid innovation on the client happening. So a lot of these frameworks do some serious heavy lifting for front-end development. And these things are moving really, really quickly. So I've just listed a bunch here, and they all have pros and cons, and people are pretty opinionated about which ones are great and so forth, and there can be a lot of debate there. But overall, they make developers a lot more productive, or at least people argue about how productive they make you. But I think it's an asset to have all of these different frameworks available. But what about the server? So there's actually a lot of innovation going on with REST services. And there's everything from API management to really great standards like REST API markup language is coming into play. We're going to show off a tool that we use with our application called Swagger, which is really good for basically generating live API documentation. And so that's kind of the scope of the talk. We're going to talk broadly about REST services, and then we're going to dig into the way that we've kind of thought about that particular problem and show off a quick demo to access all of these things on the back end with Angular. So just a quick context. I won't spend too much time on this. At DreamFactory, we are a development company. We make applications. And similar to the Angular team at Google thinking about the front end, as an analog, we've thought a lot about the back end. So we've done some pretty heavyweight, complex implementations with enterprise customers. And we've rewritten a lot of our code and done a lot of things over and over. So we were kind of envisioning a world of, wouldn't it be nice if we could write less code, if we had a flexible way to deploy on different infrastructures, kind of a mobile architecture, use existing data, and then have a user management system instead of having to write all of that ourselves. And so when we thought about this, we thought about, wouldn't it be great if REST APIs were provided or available and usable for you? It would be great if this thing was open source and you could install it. It would use REST and JSON as the key protocol. And then connect into SQL, NoSQL, file storage, and then remote APIs is the other kind of key area. And then provide single sign-on and role access to all of these things. So you have very granular control over what services are available to end users is the idea of your applications. So this thing that we envisioned sort of didn't exist. If it did, we gladly would have used it. And really the state of the art is kind of building these REST APIs yourself by hand, building your own kind of user security from scratch, and then building user management and all of the security around that manually, and then repeating that whole process over and over. So we open sourced this technology called the DreamFactory Services Platform. We call it DSP for short. So get some water here. Basically what it is it's a piece of software that you install on a server. We also have hosted versions of it. And it securely connects, so it provides a server-side connection to SQL databases. We support a bunch of them. To NoSQL databases such as MongoDB, CouchDB, DynamoDB, Azure Tables, are adding more and more of those. And then file storage, whether that's S3 or Rackspace. It could be local or remote file storage or own file storage that's RESTfully accessible. So it does all this, and then it automatically generates a REST API that your application can then use and you can write to with standards, with open standards. So we provide libraries for Angular and some of the other HTML5 and JavaScript frameworks, and then also native SDKs if you're doing native development. And so we generate these APIs, and then we document them, and then they're usable for consumption or use by your application. So you can think about it, you may have APIs already that you want to use. And so exposing those APIs, this is a mechanism to do that, as well as like connecting to things that don't have APIs, like a SQL database, for example, does not have a standard REST API. So this technology is absolutely free and open source. It's an Apache license. You can install it on all of these different platforms. You can install it on premises, which turns out to be really, really popular with many companies. So all different flavors of Linux right now will support WAMP stack soon, Google Cloud Platform, VMware, Windows, etc. We also have a hosted version that you can just use for free. So that's the technology in a nutshell and how it can be deployed. From a developer's perspective, you can think of it as a single interface to develop to. So on the right-hand side are all of these different data sources that may exist anywhere on-premise in the cloud, on your server in your basement, wherever it is. And then the middleware here, DreamFactory, provides that tier, that facade, or the API proxy to all of these sources securely, where generally you have to store your keys securely on a server, never in the client. And then a REST and JSON interface that's standardized and open to get to that information, and then a complete security framework on top of that. So the paradigm is very simple. You develop in Angular, for example, you make API calls RESTfully, and then you get JSON back to the client. So the things in Circle, I'm not going to spend a lot of time on this, but these are the things ourselves that we had to do in our own development, which we found lots of developers facing these challenges from configuring and building and designing your REST APIs. One of the real challenges for us has been not only all the integration, but then all of the testing that involves. when you have just so many different APIs that you need to use, it's just really hard and time consuming to build those and then test them and manage them. So we're trying to, ultimately like reduce or minimize the things that are in the circles there, and do this with small agile like front end teams primarily, was the idea. So Bitnami, the way to get this, Bitnami is a partner. They're like I guess an app store, you would call it, for open source server software. So you can get the installer, you can install it on Mac OS X, or Ubuntu, for example, or VM like VMware. And they also have a hosting model. So if you're like, I don't want to install anything, you can, Bitnami has a hosted version of it as well. And then you can also it's absolutely free. So people can go and try it out on our website as well. So now let's switch to Angular. The anatomy of an Angular application. So I'm not going to go into too much detail here. A couple of the really nice things about Angular is, number one, it's really modular and testable, for one. And then you have all these built-in things like directives, for example, the popular ones like ng-repeat, for example. And then you can extend those however you want. So it's highly extensible. So the area that we're going to cover broadly is like, how do you connect to a server with Angular? And Angular provides this really handy mechanism broadly called services. And they come in a couple of different flavors. Like you can write a factory, for example, or a service. You write that piece of code once. It could be something like as simple as a user login routine. And then you can inject it into your controllers and reuse it, which is really, really great for testing and keeping your logic and your code implemented really cleanly. And these things are lazy loaded, so they're kind of great for asynchronous use cases when you're getting something back from a server, but you're not sure like if it's going to succeed or not, or when it's going to come back. So Angular provides all of these built-in mechanisms, and what's cool about that is that you can then extend them to make it even easier. So you have all these libraries coming out, like you've got like Rectangular is a really good library that makes REST really easy, and then other companies are doing things as well where they're adding these libraries and trying to simplify the development for people. So server calls with Angular, we've got HTTP, which is an abstraction of your basic browser request, and then resource, which is great for RESTful data models. And I mentioned Rectangular, which is kind of what that does is it's a service to handle RESTful resources really, really easily, and you can get that on GitHub and check it out. So all of these work with whether you're using Dreamfactory or trying that out, or whether you have some RESTful resource that you just want to write to. These are the key mechanisms. Resource being the one that's particularly well suited to RESTful URIs. So this library that I'm going to show that just in the next few minutes is an open source module. It's dynamically generated when your application loads. So it's a library, so you drop it in, you can install it with Bower or just put it into your project. And what it does is it integrates your application with all of these services that you've added on the back end. So if you add a service to go to Dropbox or something, that service is then available, and you can just write to an API really easily. It's built on HTTP, so you don't need to use scope.apply. It simplifies that. And when you use it, it's instantly available. The convention it uses is dreamfactory.api.service, which is the REST service, .method. So it's basically like Ajax. So really nice examples of REST calls. There's egghead.io. I mean, a lot of people probably know about these. If you're new to Angular, definitely check out the videos there. NG Newsletter has a bunch of great examples of using REST. AngularJS magazine, and there's a GitHub repo that has just a whole bunch of links. I'll post this stuff up, but if you're just learning, like just dive into this stuff. And I think the way that people learn really effectively is by example. And so we'll show kind of two examples today. One that this app that you can get. I wrote up a tutorial for people to go through it because it will be a little bit fast. There's Ari Lerner spoke here. He's here tonight actually. He wrote a really good book. I picked it up and dove into it over a weekend and read the whole thing. It talks about the fundamentals of Angular. It covers scope, these kind of really key concepts, two-way data binding. And then the nice thing is it gives some examples of services and cores and things like this, which is all about server interaction. Like how do you do that? And these are like basically really hands-on examples, and I think that's how people learn the best. It's not really theoretical. You just kind of jump into it, and it's very pragmatic. So with that, I want to jump into a quick demo. So let's see. Move this over. Okay, so the application I'm going to show is deliberately, it's very simple. This is a little, it's going to show three things. So it's a little trivia application. It's responsive. You can get it on GitHub. I kind of want to show three things. It's the ability to use an API to register, to log in, and then to call a third-party API. So basically, this little application, it's going and fetching some questions. So it's using an API called Rotten Tomatoes to get these movie questions, which are actually super hard to answer. And then it's you can either come as a guest or you can log in, so you can register for it and sign in. And it's also doing some very basic database CRUD. So if you get a question right, like I don't know the answer to this, so I added a cheat button here, right? So if you get the question right, you get points. So it's basically just adding to your score, and then if you get it wrong, you get a deduction. So really, really simple mechanic. We're showing registration of creating a user. We're showing authentication. We're showing calling a third-party API. And then we're showing a database CRUD on the back end and how that all works. Now, we didn't do anything on the server except some very basic configuration, which is what I want to show. And then I'm going to show the library and how we're then using the APIs from the SDK. So the way that we set this up on the back end is actually very, very simple. So this is DreamFactory. This is the admin console. So we built all of this with AngularJS. This is where, as a developer, you would install the software and then configure everything that you need on the back end to connect to all of the resources that your application needs. So the first thing you do, like here, is I just set up an application, which is basically an API key. So I called it this, and we're actually running the application from a server, running it from my local server. So it's accessing this back end, but it's actually running on a server on my machine or wherever you could be running it on the internet. The next thing, so behind there's a little table here, so you can actually, it comes with a MySQL database. So there's this little table called Trivia Score, and you can import JSON, or you can just create a table. But typically what people do is they connect to another database. So they would have their own SQL database running somewhere. So what's nice about all this is the same application is written, but then you just connect it to whatever backend you want, and the front-end code is the same. So you just call the API, the service name, and so you can connect to a SQL database, or you can just use the native one here. The backend is really quite interchangeable. So that's kind of nice. The services, though, this is the core of really what I want to show. So if you want to add a service, you need a secure way of doing that. So here, this little service, I just give it a base URL. So it's this API, and then I give it an API key. And that's a secure way of provisioning this so that end users who are using your application, the credentials to that are always hidden. So you just can add parameters in here, and you can add headers, and then make those API calls. And I've got it several set up. So it's similar, like if you were setting up MongoDB, you just put in your connection string, and then it lights up, and off you go with that particular API. So once you've set it up, you can then actually go to the API SDK, and you can see all the methods. So this is Swagger running. And Swagger is just a live API documentation mechanism that we've put in here. So movies here just takes a really simple parameter. I'm going to do a get call on it. And it's just a string. And then I can click to try it out. And what that does is just makes an API call. And it returns this ugly response, which we then actually have to clean up on the client. And I'll talk a little bit more about that in a moment. So here you've got all of these services set up. And then, for example, the database CRUD, that's just happening on DB here. So you can just make any of these calls and you can inspect what's happening. And you just give it a table name and off you go to get the response back. So that's how we set up the back end. We just set up this quick service. We have a DB service that's available. And then we've got a user service, which has things like session management and registration built in. So that's how it works. Then the only other things that you need to do to set up an application like this is just config. So we've enabled cores because if you're writing a browser-based application and it's running on a server, like here I'm running locally, you need to take care of cross-domain issues. So here's star just denotes that I'm opening that up, or you could whitelist a server if you wanted to there. And then I've enabled guest users and I've enabled open registration. And what this does is it ties your end users to a particular role, right? So you have to provide security around all of these things you've set up. Like you don't want to just leave it completely open because otherwise anybody can just start making API calls, which is not good. So here in the role system, you've just you have some basic permissions. So it governs like what applications these different users have. Like this one only has access to trivia. And then I'm granting read-only access to this Rotten Tomatoes API, read and write on the database trivia score, and then user access to basically, I should actually make that read-only, so that you can only do certain things like create or read a user. And that's the basic paradigm for the role system and how that all works. So that's kind of a broad overview of the backend configuration. I've written all this up in a quick tutorial. So like getting this little application up and running is very, very easy. The only other thing I want to mention, people often ask, like, how did you get that movie service? How is that thing configured? And what we're working really hard on is using just a simple JSON mechanism to encode the definition of a different API, different APIs. So here, I've just, basically you add a get movies method, and this is all encoded in this JSON, and then you just upload it to the file system. And so you can arbitrarily define a REST API that way and use it. So that's kind of nice. So that's kind of an overview of the back-end configuration that we set up there. Now what I want to do is quickly show show a little bit of code here. Can everyone see this? Okay. So what we did with this little project is we dropped in this library, the Dreamfactory library, which has a service, and it's basically, it uses HTTP. So we've injected HTTP in it, and it takes a URL and an API key. That's all it takes. Two very simple constants that you specify in your app.js file. So in app.js, I have two constants at the top. So you just specify the URL of whatever the DSP is, and then you specify the API key, which is the application, so that you know when a user authenticates, do they have access to that application, and do they have access to the services that that application is using. So that's how you do that. And then I just want to show a couple different controllers here. Let's see. Let's figure this out. So a lot of people ask, like user login and setup is often a really, it can be a challenging thing with Angular. So here, I'm not going to show all the controllers, but I just want to show kind of how you would implement a simple registration in the convention here. So really, like if you read through this code, you've got this front end, you're checking and verifying a password. Somebody puts a password in, you're checking, does that password, does a string match or not? And then you're basically just making a very simple call and passing key value pairs of email and password when you log in. But before you log in, you need to register. So the way we do that is we use dreamfactory.api.user. So user is the service name that you saw back here. So all of these things here are in the SDK. So like all of the methods for user, for example, you would scroll down and you can see all of the different methods that user has. And register is here. So you can see the URL and HTTP as a post and all that good stuff. It's all documented. So really what's happening here is all that's happening is we're calling that user or whatever the service would be called, DB or MongoDB or whatever you named it, your service, and then the method on that, which is register, and then we're just passing in the data, which is just the user's information, their username and their password. So it's actually very much just like Ajax. You don't need to use scope.apply here. Of course, you can use resource to access any of these. Are just RESTful URIs, so you can also do that. But this library is just trying to simplify that for you. So that's kind of the registration controller. And then login is, as you expect, very similar. So we've actually, here you just have some post data, which is the credentials, and then you just call api.user.login. And then the logout function is basically just in the route. So if you look down at the route here in this code, you have when/logout, and then you resolve and you pass in root scope in the user service and Dreamfactory, and then you just call the logout function. So that's all there is to it. The services, so in general, like writing applications, it's good to deconstruct them and to separate your services out. So you can have your services in a separate folder as your controllers, and then your controllers are just calling those services. So we've got 5 different services here: a string service, a user service. I'm going to talk about 2 of them. I just want to show like how you use promises here. One example of that. So with this the scorekeeper service. Let's see if I can get my mouse to move here. So this service is just keeping the score. So it's passing in Dreamfactory and Q, and we've written this little private function, create record, which is just creating. So DB, remember, is the API that we're using, and then the method name is create record. And this is a private function that's kind of generic to this service, and then it just passes in record data. So we're just going to invoke it down here. And all we're doing there is we've got this create score record, and we create a promise. We provide the record data that's then going to get inserted, and then we invoke the create record function that I showed above, and then we handle the promise and then return it. So this library, like promises, is a really good approach. Like avoiding callbacks is good. It's good for testing, and it just makes your code really clean. We've built this library to work well with promises, but you don't have to. And if you go to the README file, we give some generic examples, kind of just code examples of how you can use it with promises, or if you just want to use a regular, kind of non-promise, return a function, an error, or a success, you can do that too. The other thing, this application, like for those who are new to Angular or haven't used the testing frameworks, it has test cases in it. So there's unit test cases. So you can fire up, it comes with actually Karma. So you can fire up, like if you've installed Grunt, you could do grunt test : unit, and that will kick off some unit tests. And you can actually go into the code and check that out if you're not familiar with Angular's kind of unit test mechanisms. And then there's also some E2E, so end-to-end testing, which basically what this does is it emulates behavior that an end user might be doing. So like what happens if someone's registering? And these are done with Karma, so it just fires up Karma and goes through these kind of test cases. And there are about 20 in there. So you can definitely try that out and see how it all works. The other thing, quickly want to touch on, we do a lot of stuff with mobile. So we've built this mobile application. So if you're hosting applications in it, you install DSP and you build applications and they're running on a server, in the DSP. we provide a mobile application which houses those applications, or applications run inside it, so you get the full security framework. And so that's really useful if you just want to deploy without having to, use PhoneGap or whatever yourself. This is all open source though, so you can go ahead and you can use Bower and Grunt to build it. So you can use this source code and build an application wherever you want, and then use it and package it up with PhoneGap. So like the steps to take this application that we just showed you and turn it into a mobile application is relatively easy to do. Yeah, that's probably a whole nother topic of discussion, but I just wanted to point that out, and you can go and check that out as well. So everything I showed here today is in a tutorial that I just posted yesterday, which kind of walks through, it's on our blog, it walks through how to set all this stuff up. And you can go look at the code and see how it works. So we'll do one more thing. Yeah, I mentioned the blog. The other thing, there's a basic resource tutorial. So if you want to just kind of see a very basic, it's a very trivial CRUD application, like a to-do list example of using resource just generically with a REST API. We have some examples of that on our website, which is also worth checking out. We're coming up with a bunch of new features, so server-side events and JavaScript scripting. So that example I showed with the API response coming back from Rotten Tomatoes, there was a function in this application to clean that code up because it's it can't be rendered in JSON. It needs to be cleaned up. So those are the types of things that server-side scripting take care of. So you can make a REST API call and then transform something and then return a response. So you can think of things like validation, based on some specific condition of a user, don't insert a record or do insert a record. I mean, that's a very simple example. So we're coming out with that in a few weeks. RAML support, record level CRUD security. So this is the idea of the ability to specify an arbitrary filter on things like a use case would be, never let a user do anything with records that user has not created himself. Things like that, which will apply to SQL initially, and then we're going to do it with NoSQL as well. And then we're going to do a lot of work with enterprise integration like LDAP and Active Directory, things like that, and then provide a VM for multi-tenant. So the idea there is you can spawn as many DSPs as you want. So a bunch of resources, tutorial, the app code is on GitHub. The library is all open source, that's on GitHub as well. The Cordova mobile app I mentioned. We have a bunch of developer resources, and we're working with a company called Cloud Academy. So they provide really good learning resources for different platform as a service and things like that, as well as what we're doing. So that's it. I think we're at about 40 minutes. Thank you.
We'll do questions at the end.
Okay.
Good job, Ben.
Thank you. Should hop off here.
Good, good.
All right.
Okay, we're going to welcome James DeBoer from the Angular team to come up and talk about how we do benchmarking, some tools he's developed, and where we're going with the techniques.
we've been iterating on these ideas on how to, or on the best ways to write and run benchmarks. And so possibly by next week, what I'm going to present will be out of date and we'll have something even better. But these are three things that we've figured out. The first one is that benchmarks should be real applications. Everybody can think of some pathological test cases that you can bring a web browser to its knees, but those aren't very exciting when we're trying to help real users, and also help browser developers build better browsers so that everybody has a better experience. Which brings me to the next point, is that benchmarks should run everywhere. And so we're now developing web apps not only for desktop browsers, but also for phones and tablets. And being able to run your benchmarks on those devices is really important. Not only because they have different performance characteristics that your phone will behave much differently than your Mac would, but also being able to pull your phone out of your pocket and see your benchmark running is incredibly powerful. The last point, benchmarks should be long running. This is a little contentious, and it took us a while to get to this idea, because on the Angular team we're really excited about unit testing, and we want our unit tests to be very succinct and run incredibly quickly. So we were thinking, hey, maybe our benchmarks should be the same, that we can just run through them. But it turns out that if you want a real benchmark that emulates a real application, it should run for a long time. Because if you think about your web app, very few users will open up a browser, go to your application, click a button 1,000 times, and then close it. That doesn't happen. Instead, they're spending all day working on your application. So let's look at a benchmark. So it's a little small, but here this is a to-do application, and you can see what we've done is we've instrumented it to run through a sequence of actions. And I'm hoping that these are actions that users would actually take. So you're adding 20 items to a to-do list, and then checking them all off, and then you'll mark all of them as done. And this benchmark is running in a loop, which allows us to use the developer tools to actually profile it and figure out what's going on. I have another version that runs a single loop that you can run inside of a benchmark harness, so you can hook it up to a continuous build. But this is something that you can actually dig into and understand. So if we look at the code here, this is a typical Angular application that you can see. You can see we have an ng click that does something, and there we see to-do.mark all done. And then further down, we have a little form that has a input hooked up to ng model and another button. And this is important because when we create the benchmark, what we're doing is we're just executing a sequence of Angular expressions. So we're using two things. The first is request animation frame, and that lets us execute a single expression per frame. which means that you'll see the JavaScript as well as all of the rendering together. And then the second thing we're using is Angular's scope.$apply, where you can just pass an arbitrary expression and Angular will run it and update the model. And so you can see that back here that we have this request animation frame loop, and then we can use the developer tools to capture frames. And so because we're using animation frames, there are tools that say, well, let's bunch all of the work together in a frame. And so this is the Chrome developer tools frame view. And so here you can see that each of the frames, so each of the Angular expressions took some time, and you can quickly identify, hey, there's a long Angular expression. So this one took 23 milliseconds to run the JavaScript and then render all of the any DOM updates that it had to do. And we're able to use these existing tools to drill into it. And so here we can see that this was a to-do.add, which is equivalent to clicking the add button on that to-do app. And we can also see, hey, it took a long time because there was a garbage collection event that triggered during our code to process that to-do add. And so this actually highlights one of the things that Angular is doing, that we use efficient data structures, that we avoid creating garbage while we're running your app to try to minimize the number of garbage collection events that your application has to do. And then the other thing we can do, and this is a really important point, is that you can run JavaScript profiles, and you can do this because the benchmark is running for a very long time. So you can collect as many samples as you need, where if you had a benchmark that tries to run as fast as possible, there may not be enough time to collect samples to get a meaningful profile. And so then this can be used. You can dig into this and understand why your application is slow. And then the final thing you can do is you can run this on your phone and actually use Chrome's USB debugging to see the benchmark running on that device. And I will do that now. So this is actually built into the latest releases of Chrome now, that if you go to chrome.inspect, you can see your Android device when it's plugged in. And so this is, if we go back to timeline and do the same thing we did before, so here we're getting frames coming from the phone, and you can look at each of them and see, well, first of all, they're much slower than they were on the desktop. That on the desktop, most frames were completing in less than 10 milliseconds, and here we have 48 and 140 milliseconds. And then you can also see that painting takes a significant amount of time. So next steps. This is still our current best thinking, so we're not there yet. One of the biggest things we're struggling with is how do we actually get the data off of the browser and we want to be able to do this in a cross-platform way, that we don't want to be tied to a single browser. And so even getting frames per second information out of your browser through JavaScript is very difficult. And so we're still working on this, and right now we're exploring browser-specific ways to actually measure the time from when you start your JavaScript to the time that your pixels are rendered. And so that's all for me. I think next we have Mishko.
Which one's the magic cable?
Yeah, plug this in.
How you guys doing? Really? How you guys doing? Okay. Maybe try it a third time. It's not projecting, is it? Yes, it is projecting. Okay. So I want to show you how change detection works. So change detection is basically the magic thing we have that figures out if anything has changed in a model. And we do this through something called dirty checking. And dirty checking allows us to basically figure out if an object has changed. And most other frameworks do this by forcing you to implement some kind of interface and use special getters and setter methods. And I think one of the things that differentiates Angular is the fact that there's no special objects for model access. So how does this work? Well, in its simplest form, a dirty checking is simply a comparison such as this, where you're saying, look at some value and compare it to a previous value. So here is maybe a better example right here. So you have an object, for example, and you say, does object have a particular property? And you compare it to the previous value of the property. And one of the things we would like to know is how fast can such dirty checking be? So what I've created here is what I just call an item, which is essentially our way we keep track of things. And the item keeps things like the object I'm interested in, the field on the object I'm interested in, what was the last value, and what's the next item in the linked list is. And what I do is I create a list of 1,000 items, and I give it a random value, and I link it together. And I want to know just how fast I can iterate over these items, right? So this is the first question I might have. So if you run this thing, this is my machine. It's about 2 years old. So it's not the top of the line, but you will get a number that might surprise you. And that is basically that the VM, and this is not just Chrome, but really all modern VMs, can iterate at a pretty impressive clip, about 221,000 iterations. The way this is structured, because we're iterating over a list of 1,000, it automatically divides to milliseconds. So this is how many dereferences you can do in 1 millisecond. That's a pretty big number in my opinion. But this function doesn't really do anything. It just goes to the next and next item. So let's make our first naive implementation of this thing, which would be this one. So let's go and we can edit this and let's add. So here what we're doing is we're actually doing comparison. So not only if you compare this to this previous line, what we have done is we added a comparison saying, okay, how many field references, how many properties can we reference in JavaScript? So let's save this and run our test. And I'm going to take a guess. How many people do you think, what will the number be before the number actually shows up? 20,000? Oh, you saw it on the slide, didn't you? No, it's actually a pretty high number if you look at it. And so if you look at this thing, do you think this test is okay, or do you think that the way VMs work, we got tricked? Is this a real test or not? Now we actually got tricked by the VM because you need to know a little bit about how VMs optimize JavaScript code. And the thing you need to know is this piece of code here. So when a VM, let me see if I can make this larger. When a VM sees a field reference, such as here, like when you see cursor.next, it needs to know where exactly the next field is stored in the object. And because JavaScript, there's no classes, no types, it is not possible to know this information ahead of time. And so what happens is, if a piece of code gets executed over and over and over again, VM does a little trick which says, look, I've seen this class before. There's this thing called hidden classes. Are you familiar with this? Like, you might have heard about this. So there's this hidden classes, and so it says something along the lines of like, if it's a hidden class I have seen before, then hard code the offset. I know that for this hidden class, the field A is actually located, 7 bytes off from the address of the object, and I can do a fast field dereference. Whereas if it's a different object that I'm not aware of, I have to actually look up the offset before I can read it. And this is called a slow path. And so if it turns out that if you look at our code, this is a fast path because the object is well defined over here and it's always the same item we're iterating over. But we're cheating over here because we're always dereferencing the same exact field. And so this actually gets optimized to a fast path, but it's not actually what happens in real browsers. So let's make a better test. So a better test would be so instead of, let's see, here we go. Instead of always dereferencing the same exact field, we're going to actually dereference a different field each time. This might be, but we're going to have to change our code slightly. So we are going to actually create a field. We have a random function that randomly generates a name, and then we're going to randomly assign that field into an object, and then we are going to read it over here. And let's give this a try. And you will see that the slow path is actually significantly slower. So let's give it a few. Any guesses as to how much slower it might be? It's actually pretty slow at 8,000. So where is our 20,000 number coming from? We'll get to it in a second. So what happened was the VM, the way the VMs work, and this is basically how all modern JavaScript VMs work, and this is one of the biggest speed up in VM execution, was this idea of hidden classes and being able to short circuit field lookups. Is at this point, this piece of code here is forced to go through a slow lookup because every time the VM encounters this object that's a different type and you cannot optimize it away. But it turns out that we can do a trick to help the VM. So let's do this particular trick. Any idea what this trick might be? So I'm going to show you what the trick is, and then I'm going to explain what the trick does. So first we're going to create a getter function, and the getter function simply will take the object and we will generate a piece of code, right? This is as if you manually wrote a function o dot, whatever the field name happens to be. And then we are going to copy this here. And we're going to change this to say getter. Hopefully I cut and pasted this correctly. I'm going to be on the safe side and copy it. And you want to make your guess now? So we went from, I think the number was something around 60 was the fast path down to about 8,000 being the slow path. And let's see what the final number is going to be. And again, your mileage might vary. You might have a different computer, faster or slower. But the number is going to be hopefully 20,000. There we go, 23,000. So why is this particular thing faster? Anybody wants to take a guess? Say again? Something's getting cached inside of the getter, right? So let's go back to this original thing, which was that we have our here. Oops. And so let's look at this piece of code again, right? What the VM can do is, if it has an actual piece of code, is it can say, if I have seen this class before, I can create this special fast field lookup. And the reason why this works here is because we have essentially created a new piece of code, new function for each different type of object. And because we created a new function, the VM was able to say, all right, for this piece of code, I've noticed that the object is always of type, whatever the hidden class for that particular type is, and therefore I can compute the offset in memory for this field and always have the same exact field. So in a strange way, by writing more code, you can actually execute your code faster. So shorter code doesn't necessarily mean faster code. Anyways, the end result is that you can get about 20,000 field dereferences per millisecond. Now, if you have a binding such as a.b.c, right, that would count for 3 dereferences. But we have also the new version of the dirty checking, which is now called Watchtower, which will be available in Angular 2.0, can do coalescing. So if you say a.b.c and a.b.d, the change detection will notice that the a.b part is the same and will only watch that once, and will only watch the b and d property on the last part. Now let's talk about the future of change detection a little bit. We are thinking about, so this is actually already implemented in Angular Dart, and as I said, it's being ported to the the JavaScript side using a library called Watchtower.js. And the way it works is that at the lowest level, we have this dirty checking change detection, which I have just shown you. This is essentially that loop, that tight loop that I have shown you over here is essentially what this piece of code looks like. It can dereference fields in a very efficient manner, and it produces the change information. Now, the reason why this is limited to just fields is because we wanted to be able to replace this in the future with object.observe. So we have an interface, a well-defined interface called change detection, to which we can plug in different implementations. Right now, we have this thing called dirty checking change detection, but in the future, object.observe can be plugged in here. Now, just as we can do, we can plug in and check the fields in the same exact manners. Instead of calling the fields, you can actually call functions on those objects, and so you can get dirty checking of functions. And we think that's important because in Angular expressions, not only can you data bind to fields, but you can also have functions in there, and so these functions have to be executed over and over again. And so this layered approach allows us to use dirty checking when possible, or rather use object-observe if it becomes available in the future, or use dirty checking for now, but also be able to interleave this with function invocations. And so the end result is that we should be having a faster dirty checking in the future with all of the expressiveness we currently have with the functions and expressions. I think that's all I have. Brad, should we take questions, or what is the plan?
Hello, question from me. So this is a little bit of old news, but in 1.2, the router module was separated. And I'm wondering, what is the future for routing? Are you going to encourage people to use the UI router project, or is something new in store for the built-in Angular router?
Brian,
Brian, would you like to answer that question?
I really would actually. So sorry, the question was what's the future of routing? So that's actually my job in Angular 2 is to figure out the answer to that question. So for Angular 1, I think you have a couple options. UI router is pretty good for now. I've been talking with those guys about kind of some of their ideas for the router in Angular 2. But the big thing that I'm focused on is a better story for nested routes, so having nested views in there, or having maybe two things that are parallel. There are some things with like mobile navigation, for instance, where you might want to swipe views in and out. I'm considering these sort of things, but we're still kind of early in this phase. The good news is that all of the design docs for this are online, and so I'll tweet it out again, and anyone that's interested can take a look at it. You can let us know what your troubles are. My focus is really on implementing this in ES6 using the new tools for Angular 2, but the overall ideas could easily be backported to Angular 1. So that's about where we are. But yeah, we know that this is a huge area of concern and somewhere where we're still kind of falling short of what people want. Does that answer your question, or any follow-ups? All right.
I'm just going to add that in the doc we are collecting use cases. So if you have any specific corner case or special case that we might not have thought of, please go to the doc and add a comment there. This is very useful for us.
Yep.
Thank you, Brian.
Hi. Is there a best practice to watch on DOM element changes with Angular?
DOM element changes. Can you tell me more?
For example, changes on the size dimensions of DOM element. Is there a way?
If you want to watch the size of it, like if the DOM element changes?
For example.
You have somebody who knows?
Because, for example, I tried using watch on a function where I'm going to return an object with the sizes. The only problem is that the watch is called just once, for example, for a change, but the function to check the changes is called
All the time,
thousands
yes.
of times.
And reading DOM is very slow.
Yeah, exactly.
And reading DOM also causes a reflow on a DOM, which is even another problem, which you should probably not want to do, because if you read a DOM and then write to a DOM and then read a DOM again, like you're causing all kinds of bad things to happen under the hood. Is there some events that you can listen to?
In my case, I was writing on another element. It was not that problem, but the problem was the reading that was called many times. And is there another?
Off the top of my head, I don't know of any. Does anybody know?
Yeah, I can add to that. Yeah. So in general, you either want to use CSS to respond to any kind of these changes. You don't want to do it yourself. If you really want to watch changes in the DOM, there is DOM mutation events, which are supported in many browsers, but they perform really poorly. And there's a new thing called DOM mutation observers, which performs much better and can give you most of what you want. However, this is a fairly new thing and it's not supported in all the browsers. So there isn't really a good answer. There will be a better answer in the future. But in general, trying to use the watch mechanism in Angular for this kind of stuff will push you into performance problems really quickly. So use CSS if you can. That's the best option you have right now.
I had a question to Ben on the Dreamfactory example which you gave. I did put it in the board as well. How was that session handled in that application? I saw there is a REST API for user get session. I was thinking that that is what is handling session. Is it a pure RESTful, stateful REST, or is there any context involved?
I'll try to answer your question. I'm not quite sure at the end, but basically you get a session token back. So it's like it's not using cookies, although with DreamFactory you can use cookies if you want.
Okay.
So you get a session token back from the server, and that resides for your session.
Okay, and that is what you'll use in all the communications to the
Yeah.
REST APIs. Okay.
Yeah.
So assume that I need for accessing one REST service, I need data from other REST service. So will I be calling it every time? Is it for example, I would prefer not to get those data every time. So is there any way, or is it like I have to get the data? For example, user data for accessing some other REST service, I need to pass some context information.
Yep.
So how do we do it? Is it like I have to get the user data every time before calling the next service?
Well, generally, yeah. I mean, so a couple of things. So the token mechanism. I mean, so the REST APIs. When you say other REST API,
Okay,
what
for
do you mean?
example, to get data to request a new REST service, token might not be sufficient for me. I need to
Yes.
pass some additional context. So how do I get it?
Yeah. So one thing. Let me try to answer. The JSON file that I showed. There's the notion of public and private, right? So you can have make a REST API call, and then that service could then call another service securely, for example. So you can chain things together. That's one use case, but generally it's just it's the same way that session tokens typically work.
Okay,
with
well,
Angular.
one use case would be assume that I'm trying to get the address of that particular user. Now, along with session token, I believe I need to pass some ID or some city name. So this is typically a user data, or which typically in normal web applications we store it in the session.
Yep.
So this, where do you keep it? Is it fetched again, or?
No, I mean it's a session token, so I don't quite know what you mean by adding additional data to it.
Okay, my
You
question
guys
was.
can have that conversation.
Yeah, maybe we can take it
offline.
offline.
Sure.
Yeah.
Okay.
Yeah.
Sorry.
This way, on the other side. So question about DreamFactory. So what is the difference between the online hosted DreamFactory versus on-premise? Like, do you get all the web interface configurations, or?
Yeah. Yeah, it's the same software. So basically the idea is that the hosting is just the hosting is a way to try it. So that's all free, and then but the actual binaries, the software itself, is identical, right? So you can install it on a bunch of different places, including on Ubuntu, CentOS, different flavors of Linux. We support all of those.
So you were describing the the JSON on a local file. So for the cloud version, how do you edit that? I mean the file.
So there's a file system. It's a LAMP stack. So there's a file system in the software itself, and that would be local file storage. And then you can either connect to that local file storage RESTfully, or you can connect out to other data sources such as S3, for example, which could either physically, that would be a remote call. S3 is running somewhere in the cloud. So the idea is that it's loosely coupled, right? You have all of these different data sources, and it's a unified palette of services that you're using to access all of those things. And the software itself physically resides in a server on either a Linux box or AWS, Google Cloud. VMware works very well as well. You can even run it locally on your machine. So like you can spin up a LAMP stack on your machine and talk locally for development and for trying things out. Yeah.
Yep.
Yep.
Do you have any plans for caching using Angular? For example, I think that goes to that point where we can have a request, and for example, let's say the likelihood for these data to change week from now, it's low. Have you thought on using Angular to build a service or something that will cache this data using maybe IndexedDB, or if the data is like very small, using local storage or
Yeah,
just something like that?
So that's a great question. To be honest, we haven't looked too closely at Angular 2.0 yet, but we're going to have a look. In general, our philosophy is that we're trying to address the server side piece. So we leave those decisions up to developers in terms of the way that they implement their application. So I think, with respect to local storage there, like that's not really our realm so much. But if there are things on the server that would enhance that in a way, like we need to look at it. But if there are mechanisms by which, we could optimize the experience in the client, whatever that means, I mean, sure, we would consider that. It's really driven by like what users or our developers want. Should try to listen to feedback. Yeah. Yeah. Hi.
What is the size of the client-side JavaScript library that DreamFactory has, and is there a benefit of using it connecting to existing RESTful API, which is not implemented based on the DreamFactory?
Yeah, so it's pretty small. I don't know exactly how big, 50 KB or something. It's little. I mean, I can't remember exactly, but it's lightweight. You're talking about the SDK, the Angular-dreamfactory, the library?
Yeah, just the JavaScript library. And what's the benefit? Comparing just with the pure REST Angular, for example, is there any benefit of using it if we connect to existing RESTful API?
Yeah, so I mean, the benefit is sort of the key takeaway of what we're trying to convey is that the use of the SDK is to consume these services that you define. So like, say you had 100 APIs that you needed applications to access. You would define those APIs, and they would live on a server in a DSP. And then the SDK then knows about those 100 APIs. So you can write your application and call any of those APIs. And then the role system governs the permissions around those APIs. So in other words, if I'm an end user, I'm only granted certain permissions. So you think in an enterprise context, especially, there's a lot of applications and you want to manage them all because users have different rights.
I understand, but the server side is already implemented. So without the DreamFactory server side, is there any benefit from the DreamFactory client side library?
Well, the benefit is just trying to simplify the amount of code that you write and just using a simple convention. That's all. It's just attempting to make it easier. And I was trying to show there that you can use this built-in libraries as well because it's just a standard REST URI.
So what server languages and frameworks did you use for DreamFactory?
Yeah, so we use, so on the front end, we use Angular. We started about a year ago. On the back end, it's actually been a pretty interesting set of decisions. It's interesting because, so the short answer is we're using PHP and Laravel, or we're going to switch to Laravel. We're using Yi right now. The decision for that has been interesting. The drivers are actually, PHP is very mature. It's well understood, especially by large enterprises. The library has actually existed for us to do a lot of the work that we needed to do. And that was the core decision we made there. But what's, from an innovation perspective, there's a lot going on, especially with technologies like Node.js and things like that. So what we're trying to do is have our large, think of Fortune 1000 types of companies drive a lot of the technology decisions we make. And to the extent that those technologies, even Java is a huge one, are, sort of needed by enterprise customers, then we will consider that. But the main thing has been PHP, Laravel, and backend, or Yi, sorry, in the backend, doing all of the API translation or creation, provision, whatever you want to call it.
And this is a question for Ben as well. Do you have a personal preference in REST Angular or HTTP or resource?
What was the first one you said?
Like HTTP or REST Angular or resource?
So I think REST Angular simplifies things a lot. So it's just convenient and it's open source. So it's all of these things are sort of a decision around, as long as it's easy for you and you think it's going to be something that's going to be around, it's fine. I mean, I think for RESTful, interaction resource is good, and Rust Angular is good too. Just depends on what you like.
Going back to that local storage question, you said DreamFactory does not implement anything on the client side for local storage, but is there any Angular modules that do any local storage utilization or utilities that we can possibly use rather than do it natively?
Yeah, I'm not sure what there is for Angular 1 for this. For Angular 2, we're focusing a lot more on offline and client-side storage, and later on even more utilities to make the kind of client-side caching of data sets for offline use later easier. But I'm not sure what there is right now for Angular 1. There's a design doc, though. I think Brad tweeted the design docs link a couple of weeks ago or a week ago. There's a data persistence design doc that covers this in a lot of detail. There are several, but data persistence is the best one. So just look for that one.
Thank you.
I have a quick question about performance benchmarking. So what approach will you take for something, for example, like Gmail, which is very complicated? It's pulling from a bunch of different resources, servers, and you might want to run it for, say, 6 hours just to see what the behaviors are like after a long time. What would we recommend for something like that?
So we do some of this internally with much larger applications than the to-do app that I showed. I think the first step is isolating the client and the server. So being able to build your application without needing to go back to the server, and there we will do a record and playback of any HTTP requests you make, and then after you have that, so you can run your application just on your local workstation or on a continuous build somewhere, writing a lot of test cases, and at Google we have a very robust production monitoring system, so we can see, hey, there's a certain view that users are having a really hard time with, that it's taking a long time to load. So then we may go back and write a benchmark that just targets that view and add it to the suite.
Also, you mentioned that some of these tests are long running, like 6 hours or whatever, because when you want to see how the application is going to behave. I think it's important to realize that you can cheat, and you should cheat whenever you can. The important thing here is that really the application cannot do much unless there is some input, and inputs come in various forms, whether it's some set interval or timeout or XHR coming back or user input. And if you just realize that all these inputs are here, you can fast forward the time between when there's nothing happening. So you can just skip all of that, and you can just schedule the events to happen in unusually rapid pace, but it's still going to be very, very much like a production application running for 6 hours, but it's going to just take 5 minutes to run.
Quick question. The older version of the Angular docs, they had comments at the bottom, which I actually found very useful, because you have different use cases. You can other people comment on how to go about that or additional questions. I noticed that's lacking in the newer documentation. Any plans to bring that back, or what are the plans around there?
What? I wasn't listening, sorry.
Comments on comments in the docs.
On the docs. Comments on the docs.
No longer comments.
Oh, okay. Actually, you did it.
Yeah, that was me. Okay. Yeah, so you're talking about the discuss comments. All right, sorry, I also wasn't really paying that close of attention. What? Oh, could they come back? Let's see, what's the nice way to say this? So the answer is no, they're not coming back. But, and this is a good but, we want it to be easier for you to contribute directly to the docs. So there's not like, there's some stuff up here that's written by like this crazy guy, and then there's a bunch of stuff below that contradicts it, and it's really complicated to figure out what's right and which part is out of date and this sort of thing. So our hope is that we're going to make it easier to contribute just directly to the docs. So there's a single obvious source of like good information about Angular, right? So that was the motivation behind it. Like it's not like we hate having comments on the docs. Oh, where should you go for questions? Oh, so yes, that's a good question. We have an IRC channel that's really active. Stack Overflow is really good. I personally like Stack Overflow because the information on there tends to get updated pretty regularly. There are a bunch of people in the Angular community that go through these issues and update them, and it's kind of like a larger crowdsourced wiki outside of Angular, and it covers things like different use cases better than we could concisely do in our own docs. So Stack Overflow is really good, I think.
I have a question. What are the main difference of using Angular with Dart instead of JavaScript and the benefits of that?
So I guess the question is, what are the differences between Angular, Dart, and Angular JavaScript?
If I could interrupt, the bus is going to leave in 7 minutes for the Caltrain station at 8:15. So if anyone needs to catch that, then I would head out now.
I don't think anybody's leaving. Everybody wants to hear what Angular and Dart. So the difference is basically we wanted to make sure that you had a choice of a language you wanted to choose. We wanted to be to large degree language agnostic. So with JavaScript, because so many languages transpile down to JavaScript, you're actually compatible with CoffeeScript and TypeScript or whatever other future language. I think people even managed to get Clojure working with AngularJS. With Dart, the things are a little more complicated because Dart, the code is not semantically equivalent to JavaScript, and so the translated code cannot interact with AngularJS, and that was the motivation for creating Angular for Dart, so that if you wanted to choose a different language, you certainly can, but you still have the same paradigm. Now, given the fact that we were going to have to rewrite Angular on top of Dart, instead of copying everything as is, we tried to fix many of the mistakes that we have learned from ourselves from the previous version. And so you can think of Angular Dart as AngularJS++. And many of the ideas that are going into Angular Dart are now being either backported or are just directly going into AngularJS version 2.0. So things like the new compiler syntax, the change detection that we talked about, the new syntax for directives, the simplification of compile and link function. Like there's a long list of things that are going to happen in 2.0 because of the things we have learned in Angular Dart. Does that answer your question? Okay. Yes, you need to get a microphone so that it's recorded for prosperity. Or I can repeat it.
We will have like backwards compatibility of 2.0 with 1.3.
Will there be backwards compatibility? I think if you really want to do innovative stuff, it's better if you just think out of the box. And while we don't intentionally want to break you, I don't think it's going to be compatible. So the ideas will be the same, and you can probably have large pieces of code can be cut and pasted over, but it's not going to be one-to-one compatible. There's just too many changes that are done for the better to make it backwards compatible, right? It's just not possible. You can have one or the other. Yes.
In Angular 2.0, would you be able to pre-render server side, maybe with Node.js?
Igor.
Why do I get the hard questions?
How do you get the hard questions?
The simple answer is no. The reason for that is we think that we can do better on the client side, and our goal is to focus on making client side much faster. So
I think you should back up and like really break it into two different reasons why people want to do this, right?
So, okay.
Would you like me to answer that?
So the reason for server-side pre-rendering, there are two reasons why people want to do that. One is SEO, the other one is performance. SEO, crawlers have to understand JavaScript. There is no way around it, and I truly believe that this will happen soon. So we are not going to have this discussion for much longer. For performance, I think there are many things that we can do much better on the client side, especially if you leverage things like Speedy or HTTP2, HTTP push, and many other technologies that are already in the browser today. If we do that, the need for server-side pre-rendering, there is very little benefit to it, and there is a lot of complexity involved. Like we built a version of Angular that had server-side pre-rendering. We didn't like it, and it would take a lot of time to make it into something that we would like, instead of focusing on energy on doing this, which we think is, it's still going to have many downsides. We'd rather make the client side much faster and focus on that. Template pre-rendering.
You mean the thing with Tobias?
So there are some improvements in Angular 2 that we're doing that will make it possible to pre-compile templates, which means that there's going to be less work needed on the client side during Bootstrap, and that will speed up the client side further. Is that what you meant, Brad? Okay, yeah. So we are thinking, like with Angular 2, we're thinking of ways how we can run some of the template compilation as a part of the build step, and then extract metadata that could speed up the startup time. So this is one of the things that we're already doing.
This is for James. I need to measure the performance of my app kind of constantly. I'm looking for a decent, approximation of performance. And I was thinking like the average, trailing average of the digest loop. Is that a reasonable thing to measure, or do you have another idea?
So you're looking for a number that's fairly stable over time, that you can say this is what it was last week and this is what it was a month ago. That's one number. There are a lot of numbers, and the one that really matters is how long it takes to get the pixels onto the screen, and we don't have a good way of actually getting that number yet. So that did not answer your question, but we're still thinking about it. Yeah. Yes.
So question around, I guess, two questions over here. One on, I guess, migrating to 2.0, given what you just said about backwards compatibility. If I'm in the midst of a large corporate deployment, maybe I have a couple thousand lines of code that's deploying this summer, am I going to have to rewrite all that code given backwards compatibility?
Did you say 1,000?
Thousands.
Oh, thousands. Okay, I was going to say only 1,000?
A couple thousand, yeah.
As I said, the places, say? For this summer, no. For this summer, no. I missed that part.
Next summer, okay.
Yeah, you have something to worry about next summer, not this summer. But to kind of give you an idea, so the things that will change is the API surface. And if you look at your app, most of the behavior goes into what we call controllers. And most of the controls actually, if you notice, and this is something that I think we're very proud of, is that there's a very little API surface that ends up inside of your controllers, right? So there isn't really a lot of methods that you end up calling inside of it. So all of that code is kind of safe. The stuff that will change is the APIs, and therefore things how you declare a directive, things how you register a directive. There will be some changes to templating and syntax and templating, but most of these are going to be mechanical. I don't want to say regex style, but they will be mechanical in like, oh yeah, this is now that, and this is now that, and you just have to go through it. And so it's not going to be trivial change, but it's not going to be a rewrite by any stretch.
And the second part, are you guys going to look at with interface mobility performance, I guess, because I'm doing certain things maybe to get around performance for mobile right now. So is mobile a part of the focus of 2.0, hopefully?
Yes, mobile is very much a focus about 2.0. Maybe Igor, you want to speak more about this?
Yeah, 2.0 is really mobile and ES6. And with ECMAScript 6, you actually have to realize that in order to take the most to get the most advantage of Angular 2, you really should be using ES6. Otherwise, you will have to write a lot of boilerplate code. Like we will make it possible to use Angular 2 with ES5, but it's not going to be as nice as ES6. So really, when you get to Angular 2, it's going to be ready when ES6 is ready. And I think at that point, many of you will start thinking about how you migrate your code bases to ES6, which is going to be even bigger change than changing from Angular 1 to Angular 2. So at that point, I think for many applications, it doesn't make sense to upgrade to ES6 just because, or upgrade to Angular 2 just because. For other applications, it makes the sense to invest the engineering resources to upgrade the infrastructure, upgrade the APIs, and get the benefits, because it's application that you value, that your business depends on heavily, and you continually update. And because of all the enhancements in Angular 2 and ES6, you will be more productive. So, there are always trade-offs. Again, sometimes it doesn't make sense to update old code bases because it just doesn't make sense.
The mic is off.
Yes. So, question regarding like my day-to-day work with Angular. There is an Angular seed that's available on GitHub that they divide, they structure it basically like on the purposes, let's say service, directive, and controllers. And I've been talking with people that prefer to create one single file that would hold the components or the features in one single JavaScript file. So sometimes I see myself questioning, do I need to create a separate JavaScript for this directive, or should I put multiple directives inside one JavaScript file? Do you have any good recommendation for that?
I can take this one. So Angular seed, I'm responsible for Angular seed, and the directory structure that exists there was created on a plane from New York to San Francisco many years ago. And I now, since then we learned that there are better ways to organize projects. And inside of Google, we've been trying different things. Recently, I think about a month ago, we published a blog post about the best practices and conventions for organizing files in large projects that we use inside of Google. So you can go to blog angularjs.org and you'll see this blog post and also links to document that describes what the preferred structure is. And definitely for any serious application, functional organization of files is preferred, which means that you will look at your application and see, what kind of areas are in your application, and kind of break down your application according to those areas and break down files for those areas. This is something that is going to be more focused. We are focusing on this more in Angular 2, and we are going to have better version of Angular. I don't want to say we're not going to do Angular seed anymore. We're going to do, Yeoman or that kind of style of a generator where you will just have a command line tool that will just generate all this boilerplate code for you and will guide you through the process of structuring your application and files.